Voice of the Sea, learning from experts across the ocean.
Welcome to Voice of the Sea. In this episode, we journey to the world-famous Jellyfish Lake of Palau. This amazing natural wonder holds many mysteries to science and is a tourist attraction, drawing people from around the world.
Palau is a remote group of Pacific islands, home to many natural wonders like Jellyfish Lake that are found nowhere else on Earth. I'll meet the people who study Jellyfish Lake and its unique inhabitants. Gerda Ucharm from the Coral Reef Research Foundation will be my guide, sharing the tools she uses to study the lake. And research veteran Pat Cullen will explain the lake's significance. Although we call them jellyfish, jellies are not actually related to fish. In fact, they're more closely related to corals. One of your main focus is the famous Palau and Jellyfish Lake.
Yes. Well, actually, the Jellyfish Lake is only one of about 50 marine lakes in Palau. Now, marine lakes are really nothing more than bodies of salt water which are surrounded by land. Instead of being fresh water, they're salt water. That's because the rock islands, they're limestone, they're ancient coral reefs that have been uplifted. They're very porous. They have cracks, crevices, caves, all riddled through them, so that any basin, when sea level was lower, and sea level was about 400 feet lower than it is today, only 20,000 years ago. So as sea level rose after the last glaciation, as the glaciers melted, water intruded, the sea rose, water intruded back into the lakes, and it was salt water because it comes from the lagoon and the surrounding ocean. And so the lakes are salt water. They are connected by a series of underground crevices with the lagoon and ocean. So they actually go up and down with the tide, but not as much. It's like a damping effect or a filtering effect between the lagoon and the lake, so that the tide, it can't squeeze through the rocks fast enough to keep pace with the lagoon. So it lags, and it's not as high a tidal amplitude, tidal range. But they are salt water. And over the years, as they formed, and even in recent times, organisms got into the lakes somehow, either as larval forms coming in through the cracks with the salt water, other ways they could have gotten in there. So each of these 50 lakes is actually a little experiment in evolution. You have, a certain number of species introduced. You have a unique environment within that lake in terms of the size, the depth, the weather effects, the rainfall and such around it, so that some things take off and really bloom in these lakes. Other things may have gotten in there and just died out. So what we see today is a very interesting assortment of flora and fauna in each of the lakes, and each lake is different. Each one is actually unique.
How many of the lakes have you been to personally?
Personally, well, I don't spend all my time doing that. There are other people. My wife, Lori, Gerda Ucharm, who is going to be interviewed, and Mike Dawson, who's at UC Merced, University of California, Merced. His wife, Laura Martin, and a number of other people have worked really extensively in the lakes here in Palau. There's also similar lakes in Indonesia on the western end of New Guinea, what they call Raja Ampat area. That's the province of Indonesia. And it's a similar limestone area, and so they have lakes there also. So they've focused on here in Palau, Raja Ampat, and a few other areas.
And you guys look at comparisons between the marine lakes in Indonesia and those in Palau?
Yeah, they look similar. You look at a lake here, and it's a basin surrounded by dense forest and such. But the Indonesian lakes are not as deep. One of the basic reasons why people are interested in this. Decades ago, there was a group of biologists working on what they called island biogeographic theory. And that is that if you have terrestrial islands, islands of land and an ocean of water, okay, what gets to those islands? How are they related between one another? And there were a lot of general principles developed, things like the further an island is from another island, the fewer species it has, the bigger it is, the more species it has. So you have all these different things going on. Well, this project is basically turning that around and saying, okay, these marine lakes are actually islands of water in a sea of land. And do the same principles apply to the island biogeography of marine lakes versus island biogeography of islands? And it turns out that in the basics, they are very, very similar. This is the work that Mike Dawson and his colleagues have been focusing on. So I can't give you all the details. A lot of it's unpublished yet, but basically the same principles are working. The bigger the lake, the more species. The older it is, the more species, things like that. So the same general principles are acting.
Very good. The idea of the islands or the lakes themselves being a stepping stone where organisms might go from one lake to another, is that something that you know?
Not really. Unfortunately, there aren't really like a series of stepping stone lakes. You look at, like, this is a southern island here in Palau, and the lakes are, pretty much equidistant from the lagoon. This is a lagoon, so that it's less likely that you'll have things moving from one lake to another. So we don't really have enough examples to come up with a lot of information on that sort of thing. But there are a lot of different sizes, different depths, that sort of business.
And then this would be a picture of one of the jellyfish in Jellyfish Lake being eaten by its predator, the Medusavora, is that what it's called?
Yeah, this is a sea anemone called Antacmea medusavora, or medusa eater. And it's always interesting, people think, oh, scientific names are just a bunch of hoo-ha that some guy who thinks up. But actually a good scientific name is actually descriptive. And of course this is a tremendous example because it means medusa eater. So when this was described, it was a very good, very descriptive scientific name.
I was excited to jump on board with Gerda for the journey to Jellyfish Lake. Getting to Jellyfish Lake from the city of Koror takes almost an hour, but it is a beautiful boat ride through the Rock Islands. Palau's Rock Islands are made of ancient coral reef limestone that was pushed out of the water by volcanic activity. Over time, the base of the islands have eroded to give unique shapes to the islands. There are over 250 rock islands in Palau. Most of them are uninhabited by humans, but the islands and the surrounding reefs harbor an abundance of marine life that feeds Palau's residents, attracts tourists, and provides habitat for endangered species. When we got to the rock island with the Jellyfish Lake, we trekked the research gear about a quarter mile over the limestone island to the lake itself. Marine lakes are small bodies of seawater entirely surrounded by land. The land is made of porous limestone, which was formed by ancient coral reefs, and the marine lakes all have some connection to the ocean through the limestone. As a result, the lakes rise and fall with the ocean tides. Each lake has its own story, determined by the lake's degree of isolation from the ocean and its isolation from other lakes. Palau has 57 marine lakes, and many of them have jellyfish, but only a few have persistent jellyfish populations. 5 of the marine lakes have distinct subspecies of jellyfish unique to their lake. One of these lakes is Jellyfish Lake, whose jellyfish is endemic to the lake and found nowhere else in the world. Jellyfish Lake is currently the only marine lake in Palau open to visitors. The jellies in the lake were amazingly beautiful and soft. Swimming with them really felt like being in space. I saw jellies of all sizes floating by, from tiny jellies smaller than a dime to jellies as big as a dinner plate. Everywhere I looked, there were jellies pulsing peacefully in the calm waters, orange and milky against the green of the lake. I really felt like an explorer in a different world. I was really excited to learn about Jellyfish Lake from Gerda Ucharm. Gerda is a talented young Palauan researcher who loves science and has a promising career, having already studied for many years in Hawaii and in Palau. She recently co-authored a guide to the marine lakes in Palau. I was very interested in what she had to say, coming from both a science and a Palauan perspective. Ali, Gerda, thank you so much for letting me come and look at the work that you're doing here at the Coral Reef Research Foundation. I understand that you study the famous Jellyfish Lake. So what is so special about the Jellyfish Lake then?
It's totally a different habitat. There's so much that it's, for a small space like that, it holds so much, it has so much biodiversity compared to the outside. The jellyfish in the lake is only found in that lake, not in the other lakes or nor the outside.
How did that one jellyfish come to live only in that lake?
So when the water rises, when the sea level changed, all the organisms from the outside, they had access to, slowly they accessed the lake through the tunnels, and then when it reached its maximum depth, the lake, then they were just trapped in there. So they can't go out, because the jellies tend to avoid the edges of the lake because there's a predator on the side of the lake, and then the tunnels, of course, are on the side of the lake. They can't get into the tunnels, and they also need sunlight to to coordinate themselves. So they can't, in the dark, they're like totally lost without the light. So that's how they got into the lake.
So the jellies, I've heard they actually migrate back and forth along the lake with the sun?
Yeah. So they start there, they on the west side, and then they move to the east side during the day, and then they follow the sun back to the west during the night.
Do you know how they do that? Like, how do they follow the sun?
Well, the jellyfish have zooxanthellae that needs to be photosynthesized for energy, and of course the jelly depends on them for energy. So in order to get their energy, they have to lead the zooxanthellae through the light so they can continue their photosynthesis. Yeah.
Can you explain to me what a zooxanthellae is?
A zooxanthellae is the small living algae that lives in the jellyfish that gives it a golden color. Yeah.
And the zooxanthellae is able to photosynthesize, to take energy from the sun and convert it into food.
Yeah.
After hearing about the biology of jellies, I got a chance to check out the research gear. I'm always interested in the tools of the trade, so I asked Gerda to show me the equipment she uses for studying Jellyfish Lake.
So what we have here is, we call it the DS5. It records temperature, salinity, conductivity, pH, and oxygen. That's just a bigger version of this. It has more sensor than this one. It also records PAR, so the lighting, amount of light that the animals use for photosynthesis.
Can you show me how you would deploy this in the field?
So it'll go like this. And this is the fill cup. It has so much weight on the bottom, so we'll just pull it down. And that's the cable. And this is the handheld where you see all the readings. It comes up on that screen. So you connect this to this, and then you just lower it down to the water.
So you would go out on a boat to use this?
Yeah, we bring it to the lake with us all the time.
So you lower that into the lake, and then this long cable would be attached
to this, and then the other end is attached to that. We also have a downline like this that's clipped to the end of this because it's really heavy and the connectors are not really good, so it's not good enough to hold the weight of the instrument. So we're always worried that we'll lose the instrument if we don't use an extra line on it.
And does the line also help you to know how deep you've gone, or do you know that by the instrument itself?
We know it by the instrument. We have markings on the line, but it's not as accurate as the instrument.
Oh, I see. So this would be like 3 meters.
3 meters, yeah.
I see some other things here. What is this?
This is called a Nansen bottle.
A Nansen bottle?
Yeah. So we use this to capture water from the chemocline, where you see where you see the pink layer. So that produces hydrogen sulfide in the lake.
I think we maybe need to talk a little bit about what a chemocline is.
So at the surface at the lake, you get like 7.0 pH, and then when you...
Which is a pretty neutral pH, 7.
And then when you move down the water column, it lowers to about, it goes down to about 6. And then at 14 meters, it just jumped to like 8.20. That's what you call a chemocline.
So the pH is actually getting more basic at the bottom of the lake?
It gets toxic.
And why is that? Do you know?
So there's that bacteria, that pink bacteria that I was talking about earlier. It produces hydrogen sulfide, and then it traps the light so it doesn't go underneath the plate. And there's not that much mixing there, so there's no and there's no organism below there that produces oxygen. So there's no oxygen. There's nothing there that can help the water.
Would it actually be dangerous for a person to swim down to the bottom?
Yeah, actually, people who've gone there, they got rushed from the pH. So I think the last people who did that were the U.S. Navy, and then they had this like I don't know, aluminum metal suit that they had, and then they dove down to the bottom.
Let's take a look at some of the other things that you have here. Explain to me what this black and white disc does.
This is a Secchi disc, and then we use it to check the visibility of water.
So you lower it down into the lake, and when you can no longer see it,
then you pull it up, and as you're pulling it up, you're counting the marks on your line. And then so on Emilio's line, it's every feet, I think. So when he pulls it up, he counts all the marks, and then he divides it by 2, then we get it by meters.
Yeah. So you lower it down, and when you can no longer see it, then you know that that's the depth of your visibility.
Yeah.
And I think a Secchi disc is one of those neat tools that has been used in science for a very, very long time.
Yeah.
So it's easy to compare your studies in the lake with studies all over the world in terms of visibility. It's one of those standard pieces of science equipment. Yeah?
The University of Hawaii Sea Grant College Program, helping coastal communities of Hawaii and the Pacific through research, education, and outreach. Serving the community, from elementary to graduate students. Hawaii Sea Grant.
Welcome back to Voice of the Sea.
Now this is what we used to catch jellies for counting.
Oh.
So this is like 1/2 meter net in diameter.
Why is it open on the end here?
So you can release the jellies and put them in the bin and then just measure them. Yeah, so before you drop it, we tie it.
Oh,
so
I see.
And then you drop it to 15 meters, so past the chemocline, and then you pull it up and count the jellies.
And would you then compare the counts from one collection day to another collection day?
Yeah, and we also compare it with the temperature, because the number of jellies varies with the temperature. So with higher temperature, you tend to get less jellies, because the polyps cannot strobulate with higher temperature. So what they do is they just sit there, wait for the temperature to get normal, then they start releasing all these tiny jellies.
So by taking a sample at the 15 points that you have in your lake, you're able to get an estimate of the total number of jellies in the whole lake.
Mm-hmm. And then we do that 3 times. We do 3 runs for all stations. So you get to visit each station 3 times.
How long does it take you to do those samples?
Usually the whole day. Because in between each station, we take a break, like about 45 minutes to an hour, just to give the jellies some time to move toward the west, so they can be scattered. Then you can do your samples.
How many jellies are in the lake about?
So last month when we sampled, we had about 5.1 million of jellyfish.
Maybe you should tell me a little bit about the life cycle of the jellies so I can understand the polyp stage and how it makes the jellyfish or the jelly that we see swimming around.
So there are 2 stages of jellyfish, like their life stage. So there's a medusa, this free swimming adult, and then there's a polyp that sits on the bottom and wait for the time for it to metamorphose, and then it turns into tiny ephyra, then floats away. So the fertilized larvae of the female jelly, when it pops off from the female jelly, it settles on the bottom and then turns into a polyp, just like the corals. But then in time, it'll turn into a small ephyra, and when it's ready, it will just pop off and then start swimming, and then grows into another medusa.
So you have an actual weather station out in Jellyfish Lake?
Yeah.
And what is the purpose of the station?
The purpose of the station is just to help us to better understand how the weather help to mix the lake. So if you get a lot of rain and then high salinity, then you know you had so much wind to mix it, so the salinity is normal.
What kinds of measurements does the weather station take?
Rain, wind speed, direction, and then light.
Also, Jellyfish Lake is very important as a tourist attraction here in Palau. Do the numbers of people visiting the lake pose any problem for the jellies or the environment itself?
We're worried about sunscreen because everybody uses sunscreen, but we don't have any evidence of that because we don't have funding to do a sunscreen test on the lake.
Exploring Our Fluid Earth is a dynamic curriculum developed by the University of Hawaii's Curriculum Research and Development Group, teaching ocean science concepts through the disciplines of physics, chemistry, biology, and ecology. Exploring Our Fluid Earth is now available freely online. Find out more at exploringourfluidearth.org.
The Curriculum Research and Development Group in the College of Education at the University of Hawaii at Manoa. CRDG has been providing quality educational programs and services for over 40 years, serving students, teachers, parents, educators, and experts around the world and here in Hawaii. The Curriculum Research and Development Group, improving schools, improving education. CRDG.
Healthy oceans are critical to our cultural, economic, and environmental sustainability in Hawaii. The ocean serves as a source of water, food, medicine, jobs, transportation, recreation, and energy. It controls climate and weather. Kosi Island Earth aims to share this ocean awareness by partnering with local scientists and educators to engage communities and schools in active science learning for an ocean-literate population. Kosi Island Earth is working to establish new avenues for connecting research scientists with educators and communities. Kosi Island Earth is enhancing the science and ocean literacy of our island residents and visitors. Kosi Island Earth is connecting scientific research, traditional knowledge, and ocean policy. Kosi Island Earth, bringing together university, government, research, and community partners to improve science education and ocean stewardship in Hawaii.